Hello, and welcome to another video of tutoring with Leah Cremona. Today, we're going to talk about scientific notation. Scientific notation is really helpful when we are dealing with really large or really small values. It's basically about putting a number to the left of a decimal point and then some numbers afterwards, and putting a 10 with an exponent. Okay, well, I'll go over some examples in this video, so stick around to see those. So I give some tips on how to keep track of whether the exponent for the 10 is positive or negative. Be comfortable with using scientific notation. In chemistry, it's pretty important, as numbers will get really large or really small depending on which problems you're doing. So example 1, so write this value in scientific notation. Okay, so one thing we have to know is that we're going to have some number, a decimal point, some numbers after the decimal point. It could be 1, 2, 3, 4, and so on, depending on the case. And you'll have a multiplication sign with a 10, and you'll have a number here. This number here can be positive or negative, depending on the case. It has to be correct according to the value, the original value. The thing here is that there can only be one number here. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be 10. If it's 10, the decimal point's just going to move one space over here, right? Only one number can fit here. And then we'll have some numbers here. So for this case, we know that we have to move it until we hit a number. Here, if we move the decimal point over 3 places, 1, 2, 3, right, our first non-zero number, right, so 5 point something, so 5.907 times 10 to something, right, some exponent here. The first step is to move the decimal point until you only have one value to the left of a decimal point. And then put the numbers afterwards, like after the decimal point here, if they're non-zero. If we just had a bunch of zeros going out here, we don't really have to write that, right? If you put 1 0 here or 2 zeros here, it's still the same value. So now we have to figure out what exponent to put here. Now this exponent here is based upon how many decimal places you had to move the point to get to this, to get to having one number before the decimal point. So as we see here, we had to move it 3 places, right? So 1 here, 2 here, 3 here. So it's going to be a 3. And now we have to figure out whether it's going to be positive 3 or a negative 3. One way of thinking about whether it's going to be positive or negative is to see from this value to this value. So from this to get here, we have to move the decimal point to the left. It has to go to the left to reach our original value. So if from scientific notation to the original non-scientific notation form, you have to move the decimal point to the left, the value of the exponent will be negative. It's kind of like thinking about a number line where you have 0 in the center. You have positive numbers over here, right? These are all positive, and the numbers over here are negative. If you have to move your decimal point in scientific notation to the left to get to the original non-scientific notation value, you have a negative exponent. If you have to move it to the right, you have a positive exponent. So let's do an example where you have a positive exponent. So write this value in scientific notation. This kind of can show you that when we're writing numbers, we don't want to write all these zeros every time we have to write 999 million. We just want to write a shorthand. Like I said, we need to have one number here in front of the decimal point, some numbers here, and an exponent with its sign here. The original number here is this. Now we know we can only have one number here. Put 9.99. Okay, I'm just putting the decimal point where I only have one number here. Okay, right, so 1, 2, 3, 4, 5, 6, 7, 8. So I had to move it 8 places to get here. Right, to scientific notation. So I know that my exponent is going to be 8. Now whether it's positive or negative, we can figure out here. So from this to this, right, the value here, the point here has to move to the right, right? It needs to go this way. But you have to move the decimal point to the right from scientific notation to non-scientific notation, the exponent is going to be positive. This would be the scientific notation for this number. The 8 would be positive, so it just stays like that. You don't have to put a positive sign. It is assumed when there is no sign that it is positive. So example 3, what if you have 1? What if you had this and they're telling you to write it in scientific notation up to 1 decimal place, so to the 10th place. So here, this would just be, so we have one value before the decimal point. We have to the 10th place afterwards, a 0, right? 1.0 is the same as 1, same value. Okay, and then we have an exponent. So here, in this case, because the value is 1, right? The decimal point doesn't really have to move anywhere, right? It just stays there. So it just moves nowhere, right? So it moves 0 places. So the exponent would be 0, because we know that 10 to the 0 is just 1. Anything to the 0, so any number, let's just say n is a number, any number, to the 0 is going to be 1. Okay, so that's how this one would work. So example 4, if you had the value 457 and they told you to write it in scientific notation up to 2 decimal places, so to the 100th, you would have your first number. So you have to move it 2 places in order to have one value before the decimal point. So 4.57. times 10 to something. So we just move it 2 places, 1, 2. And from this value to 457, from this to this, you have to move the decimal point to the right. So when we move it to the right, it's going to be positive. So this 2 is going to be positive. Therefore, this would be the scientific notation for 457. Another way of looking at this, if it helps, is that if you, let's just take this example again. So if you have to move the decimal point to the left to get scientific notation, right? So here, the point is here originally, but it has to move to the left to get to scientific notation. You know that the exponent will be positive. Because also, you can think about it that 457 is greater than 1. So if values are equal to or greater than 1, the exponent will be positive. That is when the original value, the value written in non-scientific notation, is equal or greater than 1. If, however, the original non-scientific notation form is less than 1, right, meaning that it has this decimal point here before, so it's less than 1, then the exponent will be negative. So if you have to move the decimal point to the right to get scientific notation, then the exponent will be negative. That's another way of looking at it. Also, if there are positive or negative values, let's say this was negative, this was negative or this was negative, you just put the negative signs with the numbers. So if this is negative, right, so we have negative 457, and they told you to write in scientific notation, it would just be negative 4.57 times 10 to the 2. Right, so the same rules apply, it's just that you're adding a negative sign if they tell you there is one.
Thank you so much for watching this video. Remember to subscribe if you're new. And please let me know in the comments if you found this video helpful or if you have a different way that you solve these types of questions.